Hey folks, welcome back to another video. Today we're looking at question 17, literal combinations of a phone number. The way we'll be approaching this problem is by using recursion, so let's jump right in. Before we jump into the problem, we would use this map, and we'll see in a second how we will be using that. Right. So the first thing that we need to do is to initialize a list of strings that we will be returning. Let's do that. And then the next thing you need to do is to check the length of the digits. If it is 0, you don't really need to do any kind of computation, and you would return the list as is. Return L. The next thing you need to do is send in create a recursion helper method. And what would you need for that? You would need a string builder. Let's initialize that. The reason why we use a string builder and not the string itself is because adding to a string builder is less expensive than doing that to a string, since strings are immutable. So right, we take in a string builder, and then you need to pass in the index that we're looking at within digits. So let's pass it 0. You need to send in the list that you're appending to and the digits itself. Right, and then once we are done with the method, you would just want to return the list. Perfect. Okay, so let's go to the helper method. It's not really returning anything since we'll just be returning the list. Looking at all the parameters, string builder SB, int index. What else do we have? The list of strings, and then the digits itself. So string digit. Perfect. So what's the base case for this? The base case for this is that if the particular index that we're looking at, if it is greater than or equal to digits.length, that means we have already looked at all of the digits in this particular string that's given. So what you need to do then is to convert the string builder that you have to a string and add that to the list. So l.add, right, and then in the end you would just return the list as is, so that we know when to stop. But what's the meat of the solution, right? The meat of the solution is you need to first get which combination, which of the strings we'll actually be playing with. So let's call it string.s, and you're getting, you're pulling it from s, the strings, the string area that you have right here, and then you would say digits dot character add. We know which character that we're looking at since we're keeping a track of that using the index, but you would want to subtract 0 from that just to get, since you're getting the ASCII value, and you want to subtract 0 to get the value that would match right up here. So once you have that, you know which string you're playing with. And then you just need to do a for loop. A for loop, you would say for int I equals 0, I less than s dot length, increment I, right, and you're incrementing I, and you're saying, hey, s dot, the string builder that you have, append the particular character to that, s dot character add I. And then once you've appended the character, you know it's good, at least with that particular combination. So you would send it back to the helper to add more to that, but increasing the index by 1, and then you'll send the list itself and the digits. And to append the other characters that we see, you would just remove the character. Remove, or actually delete character add. SB dot length -1. Perfect. Let's run this code and see if it's okay. The first test seems to be okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is 4 to the power of n, and they're multiplied by n. The reason why it is the way it is because for every single digit, you could possibly have four characters that you're playing around with. So 4 to the power of n, since there are n number of digits in the string that's provided to us, and that is multiplied by n because you need to actually join it. So this part right here where you're appending it and sending it back, that is, you need to do that n times for n digits. So this is the time complexity, and the space complexity is of n, since we are using a list to actually add all of the resulting values. Perfect. So that's the solution to this problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe. I would really appreciate that, and see you all in the next video. Peace.